Hey everyone, it's Justin again. In this video, we're going to be learning how to find intercepts from a table of values. With a graph, you just look at the axes and you can find the intercepts. With equations, you plug in 0 for one variable and solve for the other. But what if all you were given was a table of values? In this case, it'll take a little more thinking and logic, but it can still be done very easily. In this example, here is the x-intercept, and here is the y-intercept. Well, how do we know that? Remember the defining feature of intercepts. One of the values is 0. This is how we'll find the intercepts from a table. Find the points where either coordinate is 0. But it's not always that simple. This table doesn't have a 0 for x or y, but we can find them by continuing the pattern. First, we need to find the slope. You'll see y in a moment. Using the top 2 points, we can get that the change in y is plus 5 and the change in x is plus 12. So the slope is 5 over 12. This tells us the pattern is that y goes up by 5 and that x goes up by 12. We can use this pattern to expand the table. Look at the bottom. If we add 12 to the x value twice, we get 0. Anytime x goes up by 12, y goes up by 5. So here's the next 2 y values. So the y-intercept is 0, 30. To get the x-intercept, we have to add rows to the top of the table because we have to reverse the y until it hits 0. Luckily, we only have to reverse it once by subtracting 5. If we subtract 5 from the y, we also subtract 12 from the x. So here is the x-intercept, negative 72, 0. Here's another example. Right off the bat, we can already see the x-intercept. The y-intercept is hidden though, so let's find the pattern. The slope is negative 1 over 2. So every time y goes down by 1, x goes up by 2. In order to find the y-intercept, we need to keep the table going until the x is 0. Then we use the pattern. Whenever the x goes up by 2, the y goes down by 1. The y-intercept is 0, negative 3. For our next example, neither intercept is shown, so we'll have to search for both of them. The slope is negative 10 for the y and negative 15 for the x, which reduces to 2 over 3. So anytime the y goes up by 2, the x goes up by 3. So let's try extending the table down. If we keep the pattern and subtract 2 from the y, the x has to subtract 3, but the x and the y just got further from 0. So we don't need to add rows to the bottom, as it turns out. We need to add rows to the top. Since negative 10 is closer to 0, let's try to find the x-intercept first. To go from negative 10 to 0, we add 10 to the y value. But then we need to add an appropriate amount to x. The slope said 3 x's for every 2 y's, so how many times do we add 2 to the y here? Well, adding 10 is like adding 2 5 times. So if we added 2 5 times to the y, we should add 3 5 times to the x. So then if y goes up by 10, x has to go up by 15. To find the y-intercept, we'll do the same thing again. For the x to be 0, we need to add 30. Adding 30 to the x is like adding 3 10 times. So we need to add 2 times 10, or 20, to the y. So the x-intercept is negative 30, 0, and the y-intercept is 0, 20. Let's do one more example. This will be the hardest one by far, but with everything we know now, it'll still be a breeze. First, if we check the slope between any 2 points here, we will get positive 4 over negative 16, which is negative 1/4. This means that when the y goes down by 1, the x goes up by 4. If we look at the table, we see that the x will be 0 in between 4 and negative 12. and the y will be 0 in between -2 and 2. So let's look at the x-intercept first, where the y is 0. To go from -2 to 0, we had to add 2 to the y. Adding 2 is like adding 1 twice. So according to the slope, we need to subtract 4 twice from the x, meaning we subtract 8. So for the y-intercept, now going from -12 to 0, means that we added 12. Since we added 4 3 times to the x, the slope says we should subtract 1 3 times from the y. So the x-intercept is 12, 0, and the y-intercept is 0, 3. Whew. Finding intercepts from a table is a lot harder than finding them from a graph or an equation, but practice makes perfect. In the next lesson, we'll use our knowledge of slope and intercepts to compare word problems with graphs.